So can you give me a few examples, like practical examples about hydrostatic paradox?
Some practical example of
Hydrostatic
hydrostatic.
paradox. Like I have a presentation about it.
Is it tomorrow?
No, it's on Monday. Like I got an example about how the blood flows into our capillaries through the arteries, like how our blood pressure is same all over our body.
Okay.
And like I did for that one, like I need one more example, like few more.
Yeah. So first thing you should know about like hydrostatic paradox, right? Like just it's all about like pressure difference. It's all about pressure difference, how it is like going up and down. So if
Yeah,
I
it is about like the pressure exerted by any fluid in a confined space.
yeah, so if I share my screen, so where is my screen here? Okay.
Like my part is about explaining how hydrostatic paradox works practically. So I took that example, but I need like two more examples, I guess.
Okay, like simple if we say like this all are level liquid and all that. If I take this one level liquid or different shape of it, okay. So in this one, what do you say, like level of height?
It is same because
Yeah,
atmospheric pressure, density, and gravitation
gravitation.
constant is like all of them are constant. So it
Hmm.
only depends on the height and the pressure exerted by the fluid on the bottom of the container is much greater than that of the top. So basically, because of the height and the same pressure at the given depth is same. So if the pressure is increased in the horizontal pipe or decreased, the same thing happens with all the vessels connected to it.
Exactly. So this all depends upon main thing is what height
Yeah, and the volume of the container, its shape or cross-sectional area doesn't matter in the measure of
matter doesn't matter.
fluid
Yes.
pressure.
Yeah. So with this, some you can try some example. Like I'm not getting any idea of example right now. As of now,
So
I'll
like
think of it.
I one is to like blood pressure, like
Yeah,
that
that
is
is
liquid
common thing.
pressure,
Yes, we can say that.
and we can see to determine different other body fluids in our body, like plasma and all, like kind of.
This will come. This will come under this blood pressure only. This thing will come under blood pressure only. But any other practical example, like some other like scientific way, I'm not getting any idea right now. So let me think and I'll tell you.
Okay, sure.
Okay, I'll just keep in mind. Yeah, how to give examples. Yeah, fine. So did anyone join? Okay. Hi, Janvi. Janvi. Yeah,
Good evening, sir.
good evening. I'm just trying to pronounce your name correctly. Okay. So let's start. Today, I think so there is no chemistry class. So we can extend our timing maybe. Let me check. Hmm, where is this? No chemistry class today. Okay. Maths class is at 8:45. Oh, your class will go on till 9:45. Yeah, good.
No, it goes till 9:25.
Okay, 9:25. Yeah, good. You're working hard to learn. See, whatever hard work you do, let it be little bit or more. Like hard work never fails. Same example, you can see me, like I studied like 12th standard so nicely. 11th till 11th I was okay. But 12th I studied it nicely. Then I, after completing my aeronautical, I joined some company. Then few months I worked there that I didn't like. So I was interested in teaching. So I came there. So for this teaching, I don't have to revise and all that thing. I just need a topic and I can teach anything because I studied that time. So that hard work never went away. So likewise, every time you have to do some hard work with some your smart work and all that. Little smart work. While solving some MCQs, you need some smart work. Get some ideas. Get some ideas. Small things. This J mains is not so difficult. They have made so much like hype that it's so difficult. No, no. Toughest exam is advanced and UPSC. These two are tough exam for mains. Both mains, prelim, UPSC is easier, but mains is tough. CSAT 1, 2. Yeah, that's not good. Let's not go there. So what we were discussing about? First law. So what was first law? Aditi, what was the first law?
Sir, it stated that if a certain quantity of heat is added to a system, a part of it is used in increasing internal energy, and the part of the internal energy is used to perform external work. So dq is equal to dw plus du.
Oh, one small changes, like what you said, last part. Say that again. Part of, not internal energy, part of,
Part of du is used
yeah,
in performing
okay.
external work.
And part of heat energy. Like, see, heat is separating like two ways. We are using heat as a heat engine in this, as yeah, that's correct what you said. In this chapter, mostly we'll focus on heat engines and cycles, heat cycles and not Carnot cycles and all that, refrigeration cycle, all that. Okay, so main purpose of thermodynamics is heat engine. Other part, like we can get as refrigerator cycle, we can reverse it, fine, that is okay. Refrigeration means reverse cycle, but main part is heat engine. So that's why the name itself says thermodynamics. So heat is distributed in some part as energy, some part as work done. Now, can you give me some heat engine example where we will use heat engine? Janvi, let me start with you this time. Can you try some example of heat engine? Where we will use heat engine? Janvi, can you hear me? No idea? Okay, what about Aditi? Any example of heat engine? Or where we will use heat engine?
Something like a hairdryer or a geyser.
Yes, a geyser we can say.
A steam engine, like in trains, the ones which work on coal.
Yeah. So big power station, also instant thermal power station.
Refrigerators.
Refrigerators,
Yes, that is reverse cycle.
like it cools down on the inside where it sometimes it becomes hotter like on the outside, when you touch the back side of it.
Yeah. See, difference between these two refrigerator thing and heat thing, that is, there we are taking heat as a work. In refrigerator, we are removing heat, but we are taking as removal of heat is your work. That is a word like difference. Removal of heat is our work that in your refrigerator cycle or refrigeration. Okay. Chalo, take it. So here du equals to, sorry, dq equals to du plus dw. That is our main formula we need to remember. Now let's see about heat. What do you mean by heat? What is heat? Yeah, can you tell me what is the difference between heat and temperature?
Temperature is a measure, while heat
Me-
is a form of energy.
Then what does this temperature measure?
Amount of heat transferred or absorbed by an object.
Yes, good. So if I simplify your statement, it is amount of or heat absorb or release that you said, fine. So we can say like how much hot or cold it is, right?
Yeah,
If you simplify it this way, that is how much hot object or how much cold it is. So temperature is a or measure of, yeah, we can say like a measure of hotness something or coldness. And heat is what? It's energy.
it is a form of energy.
Yeah. Does this heat depends upon temperature or temperature depends upon heat, something like that? Can we find some difference between the heat and temperature? One thing we said, okay, definition wise, okay, fine. Both of you can participate.
Heat is like it's like a variable, while temperature of certain things is constant. Like you can find out temperature, but we can't find the accurate amount of heat because it keeps increasing, decreasing. While temperature, we can assume a approximate value for any object. Like we can say the temperature of ice is like 0 degrees, like it freezes at 0 degrees, but we exactly don't know at what how much heat it is transferring or absorbing to get into that state.
Okay, nice. Fine. So let me simplify your words. Like heat can be like what? Energy exchange,
Yeah, it's not constant. Like we can't
constant.
specifically say like this amount of heat is released or absorbed to get into a specific state, like from water
So
to solid, like that.
by your statement, do you mean that like to measure heat, we are using temperature?
Yeah, like we are not exactly measuring heat, but we are taking an approximate value of heat based on different, we can say experiments if we do, and we can take a average value, and we can say at so and so value it changes or this reaction takes place. So we can call it as temperature.
Then how do we measure heat?
Uh,
If you
by
want to measure temperature,
energy transfer, like
no, like what is my point here? If I want to measure temperature, what is my temperature right now? I'll use thermometer. I'll use a device
yeah,
named thermometer, right? You know that. We'll measure temperature, okay, this is 90 degree or whatever it is, blah, blah, blah. But how to measure this heat? Any idea? It's okay, you can try, right or wrong, who cares? No idea?
We can use it like we can measure it using temperature. We can say that heat is like dependent on temperature to get its measure.
Okay, fine. What about Janvi?
Sir, I think calorimeter or like
Calorimeter. Yes, calorimeter is the device to measure heat. Okay. So this is what all about heat. So let's write some points about heat. So it is a energy. So energy can only transfer. So transferred from a system to surrounding, or what? Reverse?
Surroundings to system.
Exactly. Then when does this happen? When heat exchange? Just now we
Uh,
discussed. Just and you gave answer that.
It's taking place of reactions.
No,
Like
no, 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 not that way. Just make it simple. Like how this transfer of heat happens. Even when starting of this topic, I gave one example of isolation. So what happens there?
transfer of energy.
Transfer of energy. Yes, that is happening. Transfer of energy through system or from the system to surrounding, whatever, which is due to change of temperature, due to temperature difference. Heat transferred due to temperature difference. You can take same example, like if I keep a hot rod and cold rod, so it will be in equilibrium. That was our topic, remember?
Yes, sir.
So equilibrium was our topic. So it will be transferred from here to here until they are in equilibrium, fine. But so this hot temperature will move to colder body. So higher temperature is called hotter temperature and lower temperature is for colder temperature.
So we can say that heat is directly dependent on temperature.
Yes, it is. Between system and surrounding. It is macroscopic. And just now we saw it is depending on so in this one we'll say sign convention what? Like if system liberates heat, then sign convention it is negative. Absorb heat, it is positive. Yeah, make a note of it so we can scroll up.
Done, sir.
Okay. So chalo, I posted a message. There, some student replied. Okay, they're not well. Fine. Some are busy in school. चलो ठीक है. Now let's go for work. So, what do you mean by work here now? Yes, Janvi, what do you mean by work? Yes, no?
Sir, it is transfer of energy in a particular direction and it acts like a force.
Yeah. So force into distance.
Yeah.
Yes. So transfer of energy in a direction. So energy is transferring by applying force. So it is energy that is transmitted from one system to another by force moving its point of application. So if I calculate all this small work done, so we can integrate with the dW. And dW can be written as PdV, which is varying from volume 1 to 2. So volume for 1 and 2 means what? Initial condition, volume of gas in initial condition, and volume of gas that is in final condition. So actually work done in like a circular form is 0, but as it is as this is an integral, so work done in cyclic process work done is equal to area under cycle. Example, let's see here. So this is your cyclic process. Okay, I'm going here. This is what clockwise, right? Yeah. So this is clockwise direction. My clock works this way. Yeah, clockwise. Yeah. This is a clockwise direction. P2, P1, V1, V2. So this will be positive. If same manner, if I go for it's not clicking here. If it is moving in opposite to this, that is your anti-clockwise. Anti-clock means it is negative work. This is your positive work. This is pressure axis. This is your volume axis. P2, P1, V1, V2. So remaining all this story is going to remember, just understand this integration part, then when will be positive and it will be negative. Cyclic process, positive, anti-cyclic means, sorry, clockwise positive, anti-clockwise negative. Understood this one?
None, sir.
Okay. जानवी, then?
Yes, sir.
चलो ठीक है, तो चलते हैं दूसरा. That is of what we did here. Heat done, work done. Then what we need? Third thing is internal what?
Energy.
Internal energy. Now, what will be internal energy? See, we saw heat. Heat is what? It's a form of energy, fine. So, which is transfer from system to surrounding or surrounding to system means it is transferable thing. Now, work means what? That is the output. It is the energy that is transmitted from one system to another system by force moving its point from of the application. So it is that where heat is moving, that is the work done. Now, what is this internal energy then?
So
Heat
it
is
is
moving.
addition,
Yeah.
addition of all the possible energies in the system.
Addition of all the possible energy in the system, like
Change in heat or work done, and entering or leaving of matter, like exchange of
uh,
matter.
okay. So when we can say exchange of matter and all that movement of electrons. So movement of electrons, it comes with kinetic energy.
Work done by or on the system, heat, like transfer of heat or absorbing of heat. This the total addition of all these energies gives internal energy.
Yeah, total energies will give you internal. So we can say sum of internal energy due to molecular motion. That is, molecular motion means kinetic energy. And due to molecular configuration, that is potential energy. So U equals to, let's write this way, UKE plus UPE. But there are some ideal values for it, or ideal, what do you say, formulas for this. We're not going to derive, but we'll see what is the content of it, like what's the formula. So first one will say, in ideal gas, there is, what is ideal gas? There is no intermolecular attraction repulsion. There is no intermolecular attraction. So for that, U equals to U kinetic energy, which is equals to 3 by 2 nRT. And N is the number of moles or moles of ideal gas. So internal energy is path dependent, path independent, that is point function. Third one, in cyclic process, no change in internal energy. Now, why does it not change internal energy? There is no change in internal energy because, oh yeah, you try first, then I'll give answer.
So because it's going in a cycle, like it goes in a pattern, right? So because of that, there's no change in internal energy.
It goes in pattern.
Yeah, because there's continuous movement, like we can say it's similar to
To and fro.
equilibrium.
To and fro movement, right? That's
Yeah,
what you
like
mean?
equilibrium, like even though if there is constant reaction happening, the reaction is going back and forth, trying to maintain the equilibrium level or trying to maintain the internal energy.
Yeah, correct. So we can say this is your initial condition. So initial condition means ui, then this is 1. This is your final condition uf, and again this is 2. So either you are going from 1 or 2, it will be same. So in short, du equals to uf minus ui equals to 0. So uf equals to ui, initial equals to final. So last point we can conclude here. What is the point number 4? So internal energy of an ideal gas depends only on temperature. What is this equation? Yeah. nRT. So it depends on T. Because R will be constant for that ideal gas or whatever gas, particular gas, it will be constant. And N is just a number of moles. So we are left with temperature T that can be varied. Chalo, make a note of this. Then we'll go for
Scroll down to the
application. Yeah. Sorry. Then we will go for application of this laws. Okay, while writing, let's think what could be the application. Janvi, done writing? Aditi, done?
Yes, sir.
Okay. So application can be like melting. So melting process is the application of first law. Now, what do you mean by melting?
It is a phase change.
phase change. Now, while melting, does that volume change?
No.
No, sir.
Actually, there is a very you're right partially, but we can say it does not change. But actually, if you see, there is a very minute change in volume also. But those things we are not considering because it's just little, very little. So that is negligible. Obviously, like see, if you're melting some, let's take example of any metal. We are melting a metal to mold in some other shape. See, volume we are not melting here. Means like we are not changing. But due to heat, there is some exception. Like we can say there is some change in volume, but that is very little, or we can say negligible. So we can neglect that. So while we are melting, so let's take same example, like while we are melting that some iron rod. Okay, so every point the temperature of that object, what is the object right now? That is iron rod. Yeah, I gave example as iron rod. So that iron rod is changing its temperature. It is not constant. If it is constant, then it won't melt. But outside temperature, whatever it is, we are providing temperature that is constant. Okay, high temperature we are providing. But that thing is not immediately melting. It is taking some time till that iron rod reach some 3000 or 3300 something. I don't know exact value. So exactly it reaches that point, that is his transition temperature. When it reaches this transition temperature, that point, it starts melting. But still the temperature inside the object is not constant. It is keep changing until we remove the heat provided by the outside thing. Okay, so we conclude, we can consider here temperature is not constant. Inside the object, but outside we are saying it is constant. We are providing same constant temperature. We want to apply that much temperature. So that is so outside temperature we can say it is unchanged, not changed. But inside it is increasing so that it starts melting deadly. So full liquid it will become. Now next example we can say something like boiling, same thing. Melting here, then next is here boiling. So what about boiling? What is boiling? What do you mean by boiling?
The point where a liquid or any other object melts and starts to form, which is already melted and starts to form vapor.
Yeah. See, it is similar to melting only. Melting is for solid thing to melt. Now, melting will, if you change the name of melting, it will be something we give as a boiling, but work is same. Now, boiling means liquid will turn to vapor or whatever it is. Another form, that is gaseous form. So that is what melting means, process of solid to turns to liquid. Boiling means a process of like liquid turns to gaseous form. Now, what about volume here?
At boiling point, the volume changes.
Volume changes.
Yeah, because it's basically turning into vapor, right? Into gaseous form. So we can't exactly get back all the molecules together if we are freezing it again. There'll be certainly a noticeable change in volume.
Yeah, there will be some change in volume. Okay, so let's write some example and all that. some examples of formulas, some conditions. Oh, battery also low. Okay, so let's generalize what we discuss here, all that. First law. How can we generalize first law? It is just conservation of energy includes possible change in internal energy. So application. Are you guys tired? Janvi? Shall we do some writing part? Are you guys tired or not? Tell me clearly.
Kind of. Not totally.
Kind of.
Yeah.
Okay. What about Janvi? Then shall we call for the day? Call off? Chalo, ठीक है. Fine. Then we'll do writing part next class.
So can you
Application.
show the last point you wrote?
Oh
The
yeah.
first.
It is just same thing. What we discussed in this first thing. Same thing. Conservation of energy that includes possible change in internal energy. I just wrote in some other words. No, that came in my mind, so I just wrote. It's up to you. Yeah. Then application we'll see tomorrow. Melting process, boiling process, and all that we'll see. Actually, it will take some time, no, this chapter. I like this chapter. Specific heat capacity, we'll see, yeah. Heat. Second, zeroth, and J question. Chalo, theek hai. See, once basics are clear, na, that's it. Nothing to worry. Khatam everything. Chalo, theek hai. Shall I stop sharing?
Previous.
Sorry, what?
This chapter is pretty short on NCERT textbook.
Is it?
Yeah, like it only has like 11 parts. Like few are small and one or two are only big. Otherwise, it only has 11 parts.
Okay. I didn't notice that actually. I'm taking only J, so I don't know about NCERT. I just know, yeah, this chapter is there. Okay, yeah.
Like the part we discussed now was the fifth part of the fifth unit of the chapter.
Oh, actually, we didn't start topic according to my schedule, like my syllabus.
The
We have to do
next
so
part
much.
is specific heat capacity.
Oh, okay. ठीक है. So understood today's class? Any doubt today?
No, sir.
Janvi, what about you?
No, sir.
Any question, any query, anything?
No, sir.
Okay. Are you able to understand, right?
Yes, sir.
Yeah, these people are like old, like they are with me since 1 year or more than 1 year. I don't know, I'm not sure. So they know like how I'm teaching and all that. So are you able to understand everything, right?
Yes, sir.
Okay. Okay. Aditi, you are with me like since 2 years, right? 1 or 2 years? Maybe.
Since 9th grade. I think you were teaching since 9th, I
Yeah.
guess. Yeah.
Yeah, I think so. maybe 2 years. Okay.
Yeah,
ठीक है बच्चों, चलो मिलते हैं another day.
wonderful.
Okay, bye bye.